Hello and welcome to this Bioprocess International Ask the Expert webcast. I'm your host, Leah Rosen, the online editor for Bioprocess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion, and I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Christoph Harweg, Professor for Biochemical Engineering at the Vienna University of Technology.
Thank you very much for joining us. Thank you very much, and to introduce me. All the best from Vienna. I have the pleasure to introduce you to methods here which should accelerate bioprocess development. And we are doing this one with the tool Lucullus, which is a process management information system provided by Applikon. And why are those kind of acceleration tools for bioprocess development important? This is the current state of the art in bioprocess development, the bioprocess life cycle. And there you see there are still a lot of hazards. Although there is a long process development time, actually, those processes have to be developed. There is a very short revenue period only for those products here, especially for originator products. And however, although we need long time for process development, we have quite some waste fail batches here still, because the manufacturing batches are mainly based on hope, and we definitely have to change that. And our methods which we are providing here are supposed to solve this issue. I will come to this slide at the end of my presentation once again. So the deal or the goal of today's webinar is to demonstrate how generic methods based on the combination of simple measurements which you anyway have in your bioprocess can be used to accelerate bioprocess development. We are using this all-in-one tool. The tool is Lucullus from Applikon, and this is a process information and management system. So the methods I show you here are and can be also specifically implemented according to your needs into this kind of tool. And I am presenting you probably mainly microbial examples here. However, this can be also applied to mammalian systems producing recombinant products, mammalian products also like molecular antibodies, or also antibody fragments. Lucullus, shortly, is a tool for bioprocess development, for piloting, and also for manufacturing. It has four main features here, and they are based for planning. So you need design of experiments tools, for example. They are used for preparation, so there you can also make media design and filling and automated preparation of your experiments. You can execute, of course, the experiment. This one includes, of course, process control, monitoring and alarms, and of course also sampling. And last but not least, of course, the evaluation of your experiment, of your process which you actually have done. And this one includes also what I mainly present you today is data analysis, performance analysis. And of course, these elements can not only be done in a historical way, but of course also be fed back to process control here and run in real time. So in fact, we are linking today in this webinar these two issues mainly. I want to present you one basic tool which we have here, which is available in Lucullus, and this is the metabolic balance analyzer. This analyzer is based on just first principle balances like elemental balances, mass balances, and as it is a first principle tool, it does not need any specific strain information. So we can retrieve main information from databases which are available, so you don't have hassle to enter a lot of constants and elements to tailor it to your needs. And you need only very simple input variables, like you have them anyway in your process, like off-gas analysis, feed flow rates, volume of your bioreactor, and elements which you anyway have, like feed concentrations and so on. So this is a generic soft sensor which you can put here. What can you do with that? This is mainly here shown for the robust estimation of biomass, and this one can be done in induced conditions, for example, where you have metabolic load from the production of recombinant proteins, or where also for that reason the stoichiometry and the yield coefficients are time variant. When you calculate biomass here, for example, over time, then you can calculate from there very important entities for bioprocess development, scalable entities like specific growth rate or specific substrate uptake rate. I will come back to that. Why are those two entities here, the specific rates, so important? Because the only way really to develop a process in a scalable manner without surprises is to go via the bypass, which I will show you. So normally you want to develop a certain product and a certain quality, and you have to know how to put the bioprocess with certain process parameters right to get this one done. However, we don't go straight here horizontally. We go the bypass via the understanding of the cell production unit of the physiological approach. What do we need is to calculate these kind of specific rates and stoichiometries, and this one is done, for example, by the MBA analyzer, which I just have shown you. Once you have calculated them, you can use them for a platform approach to understand the relation between your physiological entity, your cell, to the quality attributes of your product, or also, of course, of the productivity and the product title. So we are going the bypass here, and I would like to show you a couple of examples why this is important. One very important element is to understand or to know what is, for example, the maximum specific growth rate, which you may have here depending on the temperature. This is a typical design of experiment, a DoE, which you need to run in bioprocess development, and where actually you can do that. You all know that at low temperatures, probably the specific growth rates may be lower. So at which levels you can actually run, what is the maximum specific growth rate? With the tool which I have shown you, the MBA analyzer, and the tool of estimating the biomass specific growth rate here, and running a dynamic experiment by, in one experiment, switching temperature, you can do in one experiment, overnight, without sampling, you can find out the area which is actually the area for optimization in your DoE. That means you don't do experiments which are actually not executable. And you find out this kind of platform knowledge in one experiment overnight without sampling. That is one way to accelerate bioprocess development. I want to show you another experiment, another advantage of this physiological approach. Here you see the task of, for example, optimizing a certain feeding profile of a fat batch process here with 3 factors normally which you need to adjust in order to know their dependency on maximum product titer, for example. This one would need here a cube design and 29 experiments. When we apply our metabolic balance analyzer tool and calculate specific substrate uptake rate, we can reduce one dimension and get actually to 11 experiments. And of course, I think that is clear that this one has reduced experimental effort. Also, this one is an approach which is a scalable feed design, because this entity, this specific growth rate, specific uptake rate of substrate, is a scalable entity. Not enough with that. You can also start including dynamic experiments, because those kind of tools inside of Lucullus are not only available in real time, but they are also capable to balance in dynamic process conditions. That means we can adjust the specific growth rate or the specific substrate uptake rate in one experiment in a dynamic way, and we can, for example, quantify the specific titer here, and we could do this experiment in a dynamic way, and you can run 3 experiments only to get to this kind of dependency of the specific titer to the specific substrate uptake rate. That means when we go back, we only here would have only needed 11 experiments. When we go to the dynamic design, we only have 3 experiments to be done. So this is another acceleration of process development. The next effect of the physiological approach here is that we actually have also increased titer by a physiological control. So when we control this kind of entity, the specific substrate uptake rate, we indeed get higher productivity compared to standard design, 2-fold, 3-fold, and this one has been implemented in development and in manufacturing also under GMP conditions. So you see this has not only an acceleration term, but also in addition it has higher productivity. What can you else do with this tool of balancing? You can, for example, have better data quality in real time from hard sensors. Here you have capacitance probe, permittivity probe, where, let's say, you normally have noisy data. You can get these data smoothed by the balancing tool. You can get a specific growth rate properly indicated in real time by the underlying balancing tool, which I presented you earlier enough. What you can else do with this kind of balancing, you can apply those kind of measurements, of course, also in kinetic models. That means you feed these data to kinetic models, and this one helps you in predicting process events, such as when is the batch finishing, when is the substrate limiting, when did I reach the maximum productivity in order to trigger an action on that. All these tools are available in Lucullus here and can be used for acceleration and optimization of processes. Coming up, so what kind of tools I wanted to show you? We use dynamics for acceleration. We use real-time, of course. We included these tools in soft sensors, and the benefits are shortly shown here. We have shorter process development times. We can ensure scalability because the entities are scalable. We can increase productivity. I think I have shown you that one. And we can create synergies to the next product and process because we developed platform knowledge. Think about the specific growth rate, temperature correlation, which I have shown you before. So we can tackle a couple of tasks in process development, saving experiments. I think I have shown you the unfolding and less dimensions. We can increase titers, and which I have not shown you due to the short time we have here, we can also apply this one, of course, to clone selection, to scale up, and also to scale down work. The effect of this approach is that actually we are having a cut down of the development time here. You see this here by 50%, longer revenue period, no waste anymore, and a higher productivity all the way. These elements are available in the tool of Lucullus. I thank you for your attention, and I thank Applikon for making this presentation possible. Here you see a couple of companies with which we have worked in order to implement those kind of tools and where they are running live. Thank you very much.
Thank you, Christoph. So our first question is, you mainly showed data on microbial processes. Can this be equivalently transferred to mammalian processes?
Yes, in fact, that can be done. Of course, mammalian processes are more complex. We have to think about different measurements, which are generally necessary to do so. But this work can be done. We have implemented elements like that here. We have tools to tailor, let's say, the sampling plan and the number of measurements you actually need to your specific process. So the tool, as I have shown you, can be also applied here. You may need some kinetic models in the background, but then you can also apply the same thing to mammalian processes, yes.
And are these tools available in real time or only in offline mode?
You can do both, in fact, here. So the historical way also enables you to analyze data also in addition with other samples, with IPC data, with other offline data which you may have available in addition to do a more detailed analysis of your process. However, the real acceleration which we would like to show here is of course only done in real time. So we emphasize real-time implementation and execution of that. And this is both possible in Lucullus, the historical way and the real-time approach.
And how much effort does it take to adapt the tools for specific tasks?
Yeah. So normally what we are doing here is analyzing the process environment which you have. That means we should first have a look what kind of data sources are available in your standard environment, and then we assess if this one is enough for the proper balancing and estimation of those entities. We are not emphasizing really just measuring more to have more data. So we are mainly having a look what kind of data you have already, and then we analyze in the second step which kind of additional data source actually gives you additional information or additional knowledge which you can apply then for acceleration of bioprocess development.
Okay. Well, thank you very much, Christoph, and thank you for joining us on your questions. The recorded version of this webcast will be made available for on-demand viewing on our website, and as a registered attendee, you will receive a follow-up email providing you with a direct link. We look forward to having you join us at our future Bioprocess International Ask the Expert webcasts. We have a full lineup covering many aspects of bioprocessing scheduled for the duration of the year. Look for those announcements in your inbox. Thanks.